Okay, we've written our app. We hand it to our friend and say, here you go. And they go, what's this? So there's the value of all the nickels. All they have to do is say, well, if we have 35 nickels, they're going to have to start counting here and work their way down. And then when they scroll, they're going to lose their place and they're going to miscount. We're going to get that's not right. It's not what I need. What I would like it to say, my friend says to me, is that 1 nickel equals 5 cents and 100 nickels equals $5 and so on. Everything in between. Oh, okay. So now we're going to be counting nickels, not 5 cents, but nickels. So we have to modify our loop. I'm going to start at 1 nickel. I want to keep going, and my friend says we don't usually get more than 100, so let's do 100 nickels. And each time up through the loop, I'm going to bump it up by 1. You could, by the way, put plus equals 1 there. Works just as well. But this is the primary reason that plus plus was created, so that you could quickly throw it in this for loop and bump it up by 1. That's my philosophy. I wasn't there when they did this, but it makes sense. It's a nice shortcut for the loops. So now every time through the loop, it should be counting by 1s. Let's just make sure that works. And you don't have to follow because it does. There we go. Everything looks good. Oh, I was supposed to show you how to fix. Oh, darn it. I'm going to undo, put my loop counter back the way it was, because remember there was a delay? Yep. I wanted to show you how to fix it. The reason there was a delay is because we're doing something that I've said a number of times you shouldn't do, and that's processing with a text box. I'm adding numbers to a text box on the fly. Every time we hit this line in the loop, it has to go out to the text box, grab what's in it, tack something new on the end, and then send it back to the text box. And then a billionth of a second later, we say, go get what's in text box, suck it back in again, tack something on the end, and it's doing this, in this case, 150 times, or whatever the magic number is there. Over and over and over again, using that text box, using the display. Here we see how slow that can be. The solution to the problem is to create a variable. So I'm going to create a string variable, and I'm going to call it output. I'm going to initialize it to the empty string, excuse me. Then, instead of adding everything to the text box, I'm going to add it to that variable. Notice I can add carriage returns to a string variable. This is making a string with built-in carriage returns. Perfectly acceptable. And then when the loop is done, simply transfer the results to the text box. Text nickel values dot text equals my output. Notice I don't want to put that inside because then I'm kind of defeating the purpose. It would still probably work. It would send the output to the text box, output to the text box, output to the text box over and over and over again. I don't need to do that. Now what's happening is we have a memory location in memory, which is high-speed RAM, and we're taking that out, putting it back in, taking it out, put it back. Okay, it's still doing the same thing, but it's doing it very, very quickly because it's in RAM versus on the screen. And so now when I say go, instantaneous. No delay, much better. I get to see my answers, and they're all there. Okay, so that's a better solution that we're going to use from now on. Create a variable that holds what you're trying to print, and then save it and just create it in memory, and then when you're done, send it all to the output.
Oh, I see.
So this is a better solution. Now back to nickels 1 and 100. And bump it up by 1. I think it worked before, but I stopped myself before I got very far. So I'm going to run it one more time, make sure I get the numbers 1 to 50 or to 100. I do. Now what do I want to do? I don't want to just display the number. I want to display something. I'm going to put a comment in here. that my format is going to look like 1 nickel equals 5 cents. We're just going to work with cents for right now. We could always modify this in the future and turn it into $2.50 when we get to the end. So that's what I want. So here, this is what I'm getting right now. It's just the 1, right? So after the 1, I want to concatenate the word nickel equals, then the value of that. Oh. How do I get the value of that? Just take the nickel times 5. Should I make that a constant? No, because the nickel's always going to be 5. And then after that, I'm supposed to concatenate the word cents. And I'm going to put a space in front of it. So what I'm doing is I'm taking this and plugging in variables where it's appropriate. So 1 nickel equals 5 cents. That should give me the same results, and then concatenate the carriage return. I will often do this. If I can't get it in my head what I want to print, I will often give myself a little format like this and work from there. Let's give it a run, see what it looks like. Not bad. Ew, 2 nickel. That's not good. So I need an S on there. But 10 cents, 15 cents, 20 cents. Okay, not bad. A little crusty because the equal signs don't line up, and being anal like I am by now, you should be. Okay, it's time for you to become as anal as I am.
Oh no.
I don't care if you're a software developer or a networker. Attention to detail is your job. Period. I don't care, and I don't care what you turn out being. If you pay attention to details as a Walmart checkout person, you'll be much better than the standard Walmart checkout person. Pay attention to details. I call it analness, but it's pay attention to details. This is a detail that I can't stand right there, those equal signs shifting. And this nickel thing is not good either. So let's deal with the nickel thing first. I really just need an S on here, right?
Then what about the first one?
But what about the first one? Very good, because the first one would say 1 nickels. Right? And the lame answer to this is to put parentheses S, which means, hey, human, you figure it out. Do you want an S? Then put it on there. If you don't, then leave it on. Yuck. Again, it's very easy for us to add an S or not, depending. I'm going to end the string right after the word nickel, because now I need to concatenate an S, maybe, and then concatenate the equal sign. So first do that. I split this string up. It used to have the equal sign and the nickel together. I now split it into 2. So it's space, nickel, then the equal sign with spaces around it. But now after this, I want to figure out if I should put an S in or not. How do I do that? A couple of ways. Don't follow me on this one. I'm going to create another variable. And I'm going to call it string S equals the empty string. And then inside my loop, I'm going to say if nickel double equals 1, let's just say not equal to 1. When do I leave the S off? Just on 1, right? What if it's 0? We say 0 nickels, right? We put the S back on again. Man, we English people, we do some weird stuff. 0 nickels, 1 nickel, 2 nickels. So if it's not equal to 1, then S equals S. Give me an S. Otherwise, and you have to remember this step because we go through it every time through the loop. Oh, I didn't really want curly brackets. Otherwise, give me nothing. Do I really need this last step? Because doesn't it start out as nothing? It does, but this is in a loop. So as soon as I put an S on, if we're not careful, it'll put S's on forever because it'll never turn them off again. So this says if it's not equal to 0, put the S on. So if it was, or 1, if it was 0, it put on the S. Next time through the loop, it is equal to 1, so it puts nothing on the end. Next time through the loop, it's 2, so it puts the S on. And from then on, the question is redundant. But we can't get away from it. That's one way to do it. That would work. And then here, I would concatenate the variable S. Now, don't follow. Let me try it. One nickel, bunch of nickels everywhere else. Let's just double check. I'm going to start my counter at 0. Notice how easy it is to change this stuff. 0 nickels equals 0 cents. Thank you very much. 1 nickel is 5 cents. And notice how nice that is and how relatively easy it was. And we're now going to make it easier still. I'm going to comment all this out because I really don't need it. I'm going to show you a different technique that I mentioned in class a couple of days ago. I'm going to use, instead of S here, I'm going to use an inline if. Remember, the inline if was an if that's embedded inside of another statement. This is a very simple question. Is the number not equal to 1? If it is, then give me an S, otherwise give me the empty string. Very simple. This is the classic example of where it would probably go. I'm going to move it down to the next line so it's a little easier for you to see. And I'm going to say, if the nickel, and I had this before, is not equal to 1, question mark. Remember, that's the syntax of an inline if, and this is where you should be following if you haven't been. If it is not equal to 1, then give me a little S, colon, otherwise give me the empty string, and that's the syntax. Now I'm getting an error because I need to surround, because this is embedded inside a concatenated string, I need to surround it with parentheses, and actually, is it nickel? Yeah. I need to surround it with parentheses so that it is treated as a group and processed first, and then the concatenation happens. That's an inline if that says, check the nickel value. If it's not 1, then give me an S. Otherwise, concatenate the empty string. And I think I would probably move this up instead and then start a new line. So there, give me the word nickel, maybe followed by an S, and then continue on. You can split it anywhere as long as it makes some sense. This is a little tricky, right? But once you've seen it a few times, it starts to make sense. It's like the if statement in Excel. We have a condition. In Excel, you put a comma, the true part, comma, the false part. In all programming languages, you have a condition, a question mark. Is this true? If it is, give me this. Colon is the else. You must have the question mark and the colon. You cannot skip either one. You must do something. So since I have to do something, I basically concatenate nothing, the empty string. Let's give it a shot. Does it still work? Still works. Good. And does it work all the way down? It should. 100 nickels, 500 cents. And oh man, it just jumped again.
No.
Making me crazy. We got to fix it. Okay, so let's fix it. Because everything else seems to be working pretty well, but we want to give our friend a nice professional product. Embedded in this program, these are not in my notes. I don't think I've ever added them to my notes because I use this infrequently, and if I ever need it, I try to remember where it's hiding. But embedded inside this program are some notes that show you how to use a string format function. We did toString, and in parentheses, we had a format like N or C or P. Unfortunately, my problem here has got nothing to do with formatting. It has to do with the width of the columns. When I go from 1 digit to 2 digits, it screws up my equal signs. When I go from 2 digits to 3 digits, it screws up my equal signs. I want each number to take up the exact same amount of space. So even though this is a 1-digit number, I want it to take up 3 places. Can't do that with a 2-string formatting. You have to use the String.Format function instead. This explains it. It's confusing. It's almost better to look at the end result. Here's some examples. It's not a whole lot better. The string format first starts with the format. This is how I want it formatted, and this is what I want formatted. How does this relate to that? The 0, remember computers count at 0? Starting at 0? The 0 here represents the first item on the list. And I could put 1, 2, 3, 4, 5 items here. And then have a 1 and a 2 and a 3 in different places and format each of them in the same command. I don't normally do that, but we could. So the 0 here simply represents this first variable that's on the list after the comma. Then comes the field width. That's the field width. How wide do I want it to appear? In this case, it's 10. It displays whatever is in value in a field that is 10 characters wide. Always. So if the number is 10 and value is 10, it displays 8 spaces, then a 1, then a 0. They are right aligned because they're numbers. The string format method is smart enough to right align numbers. Does it by default, actually. It's not smart enough, that's what it does by default. If the number were 1,000, it would be 6 spaces followed by 1, 0, 0, 0. So it always takes up the same amount of space. If you're formatting strings, name is obviously a string, you don't want those right aligned, and they normally would be. So you put a minus sign in the front, and that's the clue to the formatter that I want this left aligned. That's obvious. Not, but that's what we got to learn. What if I also want to format it, like with commas and things? Then you first specify the width, 8, then the format, N1. So if value here has 1,000, I get 1, 2, 3 spaces, a 1, a comma, yes, the commas count, 0, 0, 0. Oh, I'm sorry, I lied. That's an N1, 0.0, so I would get 1 space. A 1, a comma, a 0, 0, decimal place, and then final 0. Every character counts when you're counting characters here, particularly when you format. Here's currency. The dollar signs, the commas, the decimal places all count. And this says C2, so I'm guessing that 9 is probably full-blown if I put the number 1,000 here. I'm going to fill it. It's got a dollar sign, a decimal point, 2 decimal places on top of the 1,000. P1. Again, this was using a width of 7, but the percent sign counts. Not only that, but C#, when you format for percent, puts a space in front of the percent sign. It counts. The decimal point counts. Everything counts. So whenever I want to use this, you pretty much copy that all the way up to there. If you really wanted to, you could copy all the way up to there. Or if I were you, I would go all the way to the end. Let's just copy the entire string format, put it on the clipboard. So I just put that on the clipboard. Now I'm going to use that in my code. I want this number, nickel, to always take up 3 spaces, because at the bottom I'm going to get to 100. Maybe I'll even get to 500 nickels. The poor girl's going to count 500 nickels. Okay? I don't think I'm going to get to 1,000. If I had that much, I'd probably fire the girl and get a change counter. Solve the problem with technology. But I want this formatted. So I'm going to, first of all, I'm going to move everything else down to make a little bit of room. Stop my program. I'm going to, after the plus sign, at the beginning of the word nickel, or that string, I'm going to move it down. And then move it over a little bit. This I want to format, so I'm actually going to take it out. Paste that thing I just stole, And instead of value, I'm going to put in nickel. I don't want a 10 column space, though I could add one and you'd see the results. I just need 3. You have to figure out how many columns you need. And usually I pick a number, I think about it and say, I think 5 is going to be good. I'll put that in there. And if it's wrong, I come back and I fix it. If it's too small, I come back and fix it. So you don't have to get all technical on it and really figure it out, though it could save you a little bit of time. Let's run that. I should have a little more luck with my equal signs now. Oh, stupid nickel. Okay, that's an easy fix. Instead of displaying nothing after nickel, I'm going to display a space when it's singular. That way the equal sign will stay lined up. Sometimes it's a pain being anal, but oh, look how wonderful it looks when it's right. I get down to 100 nickels and my equal signs still line up. Man, that's awesome. Oh, except for that. I want the same thing for my value for cents. So once again, I'm going to take my cents. This is what I want to format. So I'm going to move that down to the next line. I'm going to put it on a line all by itself just so it doesn't clutter it up. And once again, I'm going to paste. Take out the 10. I still only need 3. And again, this time I want nickel times 5. So you can format a calculation. There's nothing wrong with that. And now with any luck, my output will look just the way I want it. Oh, looking good. These all line up. I can see what's going to happen. Double digits and single digits line up on the ones column. And then when we shifted to 100, it's still lined up. And oh, that's just awesome.
Mine worked without that.
Not if you get down to 100, it won't.
I'm going to retry that because it did.
Each of those numbers takes up only as much room as it needs by default, unless you format it. Yes, sir.
How come mine starts counting at 1 instead of 0?
Because I changed mine when I wanted to see the 0 nickels. I changed my loop counter to 0.
Oh, this. Yes. That is so dumb.
Okay, I was like, what the heck?
So now this is looking good. We give it to our friend and he said, yeah, that's nice, but when you get down here and it's 245 cents, my employees that I hire to work at my quick, they don't know how many dollars and cents that is. Can you translate that to dollars and cents? Okay. So here we go one more time. We don't want the word cents anymore, so I'm going to take that off and just leave the carriage return up there. I now want to format this nickel, but first of all, I'm going to multiply by 0.05. That will give me dollars and cents now. But I want to format that for currency with dollar signs so that the high quality employee can recognize that as a dollar amount. I do that inside here. Okay, but now I have to think ahead a little bit. My total got me to $5 in nickels, right? It's a dollar sign, the 5, the decimal point, 2 decimal places. So I need a width of 5 to accommodate that. And then a colon, C. And I would think the 2 there would make it more obvious that I want 2 decimal places. Just like with toString, am I right? As long as I don't go to $10, I get 200 nickels, now I'm going to be in trouble. He said 100. So the C2 there tells me format this for currency, make it a width of 5 regardless. I can tell you already I'm not going to like this.
1 nickel equals $5 cents.
It's dollar cent, 0.05, right?
Why did I-
You forgot to take the cents off, and you probably forgot to multiply by 0.05 instead of 5.
Yeah, you're.
So mine line up pretty good, and I do like it. It's not bad. But let's take it up a notch
Darn it.
to 200 nickels. That's going to take me to 10 cents, so I'm going to need a little bit more width, number 6. So I changed the loop counter to 200 and changed the width of the output to accommodate the $10. Okay, looks good.
Wait, sorry. What did that do then?
It gave me the ability to display $10 and everything still lines up except my dollar signs. Now, you may say that's not bad. We can tolerate that, Booker, and if that would be an appropriate level of analness yet, because everything else lines up. Decimal places, equal signs. The only thing that doesn't line up is the dollar sign. How do I format it so the dollar sign lines up? You pull the dollar sign out. If I always want the dollar sign in the same place, it's not part of my formatting, C2, it's just part of the string. So there's a couple of ways I could do that. I could put it here. There's always a dollar sign immediately following the equal sign, and then change this to an N so that it doesn't give me the dollar sign there as well. That's one way. Let's make sure it works. So I added a dollar sign after my equal sign because there's always a dollar sign after the equal sign. And then N2 in a position of 5, excuse me. Otherwise I'd have a space after my dollar sign. 6 was probably okay. But this thing here no longer has a dollar sign, so I don't have to count it. See what that looks like? A little extra space here, but that's what I wanted. When I get down to the bottom, the dollar signs are all still lined up. It's one way to do it. Here's another that might be a little more confusing. I put it inside my formatting string, but notice where I put it. Before this designation, it says take that number in position 0, format it for 2 decimal places. It's just part of my formatting string. I hope, I'm winging it here, I hope that gives me the same results. It does. Why am I showing you this 2-string stuff? Because that's how programming works. I want this to look better, so now I have to go find a way to make it look better. We do it all the time in Swift. I listen to my Swift programmers when they're writing their assignments, and they're going, I want to do this. Marie's been working 2 weeks because he wants to use a picker. It's basically a combo box in Swift, and we haven't covered it in class, but he wants one. So off he went, and it was a 2-week project, figuring that puppy out. I'm glad it was him, not me. Okay. Justin Walk said, I want to sort by dates. Not built into Swift, so he had to figure it out. When you need it because you want it for your output, you figure it out. There's not this logical sequence of how do you learn programming in these different languages. There is some sequence to that we've been learning here, but sometimes there's these little sidetracks. We learned about radio buttons and checkboxes with decisions because they play well together. But we learned about group boxes because we had to. Here I wanted to format it, so I had to go find out how do I make it formatted. And by the way, there's one other trick here that you haven't seen because I did it for you. I'm going to change the font. That's boring. Don't follow because you're going to undo it anyways. I'm going to pick my text box and I'm going to change the font. And notice already that it's been changed. Where is it? It's already changed. It's Courier New. I'm going to change it to my all-time favorite font. Maybe.
Comic Sans.
Please. Comic Sans? No. Curls MT. That's what. No, I don't want that either. Let's just go Wingdings. That would be fun. Times New Roman.
Tempura.
and run. I should get a much nicer looking font. Pay attention. Oh man. Do you see what I see? Look at the 9. Why aren't they lined up anymore? Oh no.
They're smaller.
Because what? They're smaller? No.
Spaces are smaller.
Because this is a proportionally spaced font. W's take up more room than the letter I. Zeros take up more room than the letter 1. And a space takes up as little room as possible, but it does take up some. It's called a proportionally spaced font. If you want output that lines up in nice, neat columns, you don't want to use one of these. Any of them. About 90% of the fonts included with Windows are proportionally spaced, probably more than that. What you need to find if you want columnar output that all lines up nice and neat like an old COBOL program, okay, and I wanted my equal signs to line up and they don't anymore, okay, you have to use a monospaced font. And those can be tricky to find, but the safe one that's always there is where I started, and that was Courier. There are others. Okay. Courier or Courier New is a monospaced font. If you look on websites, whenever they display code, they always use monospaced fonts. If we look in Visual Studio, the font that it's using is a monospaced font so that when we line stuff up with indentation to make it readable for the maintenance programmer, stuff lines up. And that's one of the reasons why my equal signs were able to line up, because I have already changed the font to Courier New. Others might look close, but if you look very carefully, they're a little wavy. Go ahead.
So if it says after the font, if it says MS, that those will.
That's a Microsoft standard font, I think.
Oh, okay. Never mind. It's tricky.
And it might work. Was it MS?
I think it might have been Comic Sans.
I'm trying to remember what it was before, what the default font is. It's MS Reference Special. I think this is Sans. There's an Outlook. I can't really tell whether there's extra space in those or not. You can experiment with them if you wish, but I don't usually mess. They're Microsoft Sans Serif. That's the default font. But notice the I. It's nice and small compared to the capital letter M. That's a proportionally spaced font. So if that was the default font, if you left the default font, just made it a little bigger, wouldn't work. It wouldn't line up right.
But there's a lot of extra math involved.
Oh, geez. Try to make the letters the same size? No thanks.
Or the space, add the correct spacing. That's
Around it, though, you can't just put a space after the letter I. You have to put it on both sides of the letter I. And yeah, anything's possible. It's a computer. My answer is no. So that's another thing to keep in the back of your mind that you as IT professionals need to recognize, is that normal fonts that people use in their normal every day-to-day processing don't work very good for us. And again, if I look at the code, these all line up nice and neat. It is possible for me using spaces to line these up. It's very hard to do with Times New Roman, to line stuff up with spaces, because it gets just this little bitty wave. And the number of spaces in front of each piece of code is never the same. It's 5 or 6 or 3 or 5. In Microsoft Word, you use tabs. That helps. Okay, but here, every character takes up the same amount of space. So there's your first example of a for loop. Again, if I trim some of this nonsense out here, that was our first example of how to add an S. If I take that out, and if this weren't so darn complicated, it's 3 lines of code. And I can generate the values for as many nickels as you want with 3 lines of code. And it's hardly even 3, it's 2, because curly brackets, I hate to count them sometimes. 2 lines of code. I can process an entire database with hundreds of thousands of records. 2 lines of code. Depending on how complex the processing is. But if it's just simple echo it out on the screen, 2 lines of code. Doesn't matter how many records there are. It's the power of loops. This is the first kind of for loop. When we come back, I got a feeling that I'm going to be lecturing at you a week from today. Keep you caught up with everybody else. I'm pretty sure, because Monday I'm lecturing again for the other. Yep, sorry. Next Tuesday is another lecture. When we come back, we're going to learn about a second flavor of for loops that has come about in the more modern languages called a for each loop. It's still a for loop. It's not quite as powerful, but it's much more convenient. Okay, and this one of the things we didn't do is this. Let's just change it so you can see what happens. As long as it's greater than or equal to 0, minus minus. Now I'm starting at 200, working my way down. As long as I'm greater than 0, keep going, and every time you do this, go down. It flips the loop. It starts at 200 nickels and works its way down to 0, and notice the space. Notice the alignment. These normal counter-controlled, normal for loops, the old style for loops I call them because they've been around since the dawn of programming. Very powerful because I can start anywhere, I can increment by any value that I want. Later on we're going to do a quiz. Our next program, a little in-class example, is a quiz percentage program. And my quizzes, the scores go up by half a point, right? We're going to go with a loop that starts at 0 and goes up by halves. Very powerful. I can't do that with the powerful for each loop. But the for each loop makes counting by 1 piece of cake. And that's why it exists, because that's what we do most often is count by ones. Starting at 0 or starting at 1. For each loop does that automatically. We'll take a look at that next time.